In this video, we're going to cover different methods for collecting data, that is, sampling methods. So to start, we're going to look at the example. We want to survey SPSCC students on how much they pay for housing per month. Give an example of each type of sampling. So our first type of sampling method is a census. So in this method, we survey everyone in the population. So you might recall that every 10 years, the US government does a census where they collect data on everyone in the population. So in this example, well, we'd survey every student at SPSCC or every SPSCC student. Now, the thing with census data collections is that it often takes a lot of time and a lot of money, and it's often difficult to get everyone surveyed. So this is difficult. It's also time consuming, it's also spendy. So it's not often used, it's not a typical or common sampling method. The next sampling method is called a simple random sample. Simple random sample is often abbreviated SRS. This is when you survey a portion of the population using a random selection. Survey a portion or a subset of the population using random selection. So in our example with the SPSCC students, you might use a computer program to randomly select 200 SPSCC students. So example, use a computer program to randomly select 200 students today. So there are computer programs out there where you will give it a list of objects or numbers such as student ID numbers, and it'll select a random subgroup of them. So a few comments about this type of simple random sample is that you want to make sure that you get a large enough sample in order to get meaningful data. So typically a large enough sample is at least 30, but here in my example, I have 200, say. So just note you want a large enough sample. Sometimes large enough sample depends on your population. Suppose if you want to get data about the entire US, then it might not make sense to have only 30 people in your sample because 30 people won't even give you one person from every state. So it often depends. Now the next sampling method is called the stratified method. So in this case, you separate your population into groups and randomly sample everyone randomly sample from every group. So I'm going to write that out. So you separate population into groups. And then within each group, take a random sample of people in that group. And randomly, oops. So visually what this looks like is if you have your population here, you then break your population into subgroups. So maybe here's your people. Your entire population are in these groups. And then in a stratified sample, you take a random selection of people within each group. So you get a little bit of representation from each group. Now, this is compared to a cluster sample. In a cluster sample, you similarly break up your population into subgroups. But then you just randomly select some of these subgroups. So maybe we just select these 3 subgroups to sample. and we sample everyone in that subgroup. So I'll write that out. So you again separate into groups and you randomly select some groups and you survey everyone in that group. All right, so a few notes about what these sampling methods look like in our example. Well, for stratified, suppose you separate students by zip code. So that's a group, a way to group students rather, and randomly select 5 students from each zip code. So you can separate students by zip code and randomly select 5 students per zip code, for each zip code. So again, that would be stratified. In a cluster sample, you could also separate students by zip code and then randomly select 3 zip codes to survey all students. So again, separate into zip codes, then randomly select, say, 3 zip codes and survey all students from those zip codes. So what might be an issue with cluster sampling? Well, you might see that in cluster sampling, you're sampling everyone from a few subgroups. So this leaves out entire groups. Which can have issues because then some of the population is not being represented. All right, so the next sampling method is called a systematic method. So in a systematic sampling method, you have a system by which you select individuals. So for example, you could survey every nth individual, where n is like, say, 10 or 100. Survey every nth individual. So to do this, you need a way of ordering or organizing your population into a countable set. So this requires a countable and even ordered population. You have to, say in our case, with the SPSCC students, you need to list all the students' names. So list all students in a list or list their names. And you'd survey every, say, 25th student. And then a final sampling method is multi-stage, so it includes a combination of methods. So for example, say first we do a systematic approach. So again, what that looks like is selecting every 25th name. And now with those names that you've collected, you can do a stratified example, say. So from those names, separate those students by zip code. And then from there, randomly select or sample 20 names from each code. So you've broken up into groups, so making that stratified, and then you're going to sample from each group. So we'll say randomly select 20 students from each zip code. So of these methods, which method do you suppose would be the best method? Just take a moment to think for yourself. So while census method is attractive because you get really accurate information, again, the difficulty and time can really affect this method in the sense of it makes this method very difficult. Well, it's difficult because it's time intensive and costs often a lot of money. But the most common sampling methods and the most useful ones are going to be the simple random sample and stratified. So we see in these situations, you get the most random representation. All right, so please take a moment to review all of these terms. It's important that you are familiar with these terms and you can identify when a particular situation is which method.